Now, let us look at it, just one simple example. What we had in the class, we took 3 examples. One example of Cobb-Douglas function, cost minimization of Cobb-Douglas function, cost minimization of a production function when inputs are perfect substitute of one another and when they are perfect complement of one another. So, let us see what we have here is Cobb-Douglas function. Fine. We are right now talking about, we have not decided whether it is a long run or the short run, we are just talking about the way we have drawn here, it is of course long run, and let us say in the short run you have something like k is fixed at k naught. Now, what you should do, you should derive the total cost curve for long run and short run, how it would look like. Fine. Okay. Let me give you how will it look like in the long run. The cost curve when we have production function as Cobb-Douglas function as production function, the cost function, remember what we had, q is equal to k to the power L, k to the power A, L to the power B. Fine. So, cost function is going to be a function of, it is going to be a function of, if you get here some, let me say A is the constant and you get it as a function of, this is what you will get if you derive. Fine. So, now let us draw the total cost curve. With respect to output. Of course, it will depend on value of A and B. Let us say, let us derive it for 3 cases. When A plus B is equal to 1, A plus B is greater than 1 and A plus B is less than 1. When A plus B is equal to 1, what do we get? Straight line. When A plus B is greater than 1, what do we get? Total cost increases at decreasing rate. Total cost increases at decreasing rate. And when A plus B is less than 1, what happens to total cost? So, here A plus B is equal to 1, A plus B is greater than 1 and A plus B is less than 1. These are the 3 conditions. Okay? Fine. Now, let us look at what happens to the average cost. Here we have talked about total cost, here we are talking about now average cost. Average cost with respect to output. When what we get when A plus B is equal to 1, average cost is fixed, is not it? Why it is fixed? We take a point here and we take any point on this curve, and when we draw a line from this point to origin, what we get? We get the same line again and again. So, average cost remains the same. What if A plus B is greater than 1? What do we get? It decreases, something like this. Okay? I do not know how much it at this point, okay? And this is, and this is increases. Again, I do not know the value at q is equal to 0, I am just drawing. Fine. Now, go back to what we discussed in the topic of return to scale. Do you find any relation between return to scale and the average cost? What happens when a plus b is equal to 1? What do we have? It is constant return to scale. Okay? And when a plus b is less than 1, what we have? Decreasing return to scale. And when a plus b is greater than 1, what do we have? Increasing return to scale. So, do we see any relation? When we talked about constant return to scale or decreasing return to scale, what we were doing? We were talking about production technology. Now, what we are doing? We are relating it to the average cost curve. An average cost curve does not give the average cost of producing just q amount of output, it gives average cost of producing q amount of output at the minimum possible cost. So, do you see any relation? Think about it.
Constant returns to scale, average cost is fixed.
Let us go with the logic. What did we say when we were talking about constant return to scale? Replication is feasible. Replication is feasible. Exact replication. So, now you have a production technology and you, let us say you have a production technology and its isoquant looks like this, fine, and you want to produce this q amount of output, or let us start with the q is equal to 1 amount of output. Okay. So, cost of producing 1 unit of output, of course, it will depend on the input prices, and in input prices in our case are R and W and 1. Now, if the production technology exhibits constant return to scale, then if we want to produce q is equal to 2, what do we do? If this is the minimum cost of producing 1 unit, then what would be the minimum cost of producing 2 units? 2c. So, what would be the minimum cost of producing q? It is going to be c multiplied by q of R w comma 1, is not it? So, what is the average cost going to be equal to? So, it is going to be the same as cost of producing 1 unit of output, considering that we are using cost minimizing combination of inputs, fine. Now, let us talk about increasing return to scale. What do we mean by increasing return to scale? So, when we increase the production, we find better way to produce the outputs. So, what will happen, or in other word, when we double all the inputs, output gets more than doubled. So, now we start with 1 unit of production, what we have, the cost is C of R comma W comma 1. Now, if you want to produce 2 units, of course, the cost is going to be R comma W comma 2, but can we say any relationship between this and 2 of R C of R comma W comma 1? Is there any relation?
Yes, sir. It is greater.
Greater, or this is going to be greater?
No, that is
This is greater. This is greater. Why? Because we are not using any return, increasing return to scale. What we are doing here, we are just replicating the process. But what did we say? When we have increasing return to scale, we find better techniques. We double all the inputs, we get more than double of the outputs. So, we do not need to double all the inputs to produce the twice the amount. The inputs, all the inputs should be increased by less than 100%. So, of course, cost is not going to be the double, it is going to be something less than double. So, this is true. So, whenever you have increasing return to scale, okay, average cost, let us look at the average cost. This is going to be less than the cost of producing just 1 unit of output. So, what further, if we consider this logic and take it further, what will happen to average cost? It will keep on decreasing, because we have better and better technique to produce. Is it clear? So, that is why we get here, look at here, that is what we get when we have increasing return to scale, average cost is falling. Fine. Now, let us look at the decreasing return to scale. What will happen? Here it is going to be greater than, the average cost will be increasing as Q is increasing. So, that is what we get here. It is not true just for the Cobb-Douglas function, it is true for depending on the return to scale. Fine. Is it clear? Okay. So, now again we can look at it from some different angle. What is happening with the average fixed cost? It is decreasing. How about the variable cost? It will decrease or it will increase? As Q increases typically?
First it would decrease, then it would increase.
Why it should decrease first?
Increasing returns to, it is normally observed that first it is increasing.
We are not talking about the any return, increasing return to scale, just explain it in using simple words.
Okay.
Average fixed cost is decreasing with Q. How about the variable cost? Of course, we are talking about the long run.
Average
short
variable
run.
cost or
Huh?
variable cost?
May
Variable
increase,
cost or average variable cost?
average variable, sorry, average variable cost may increase or decrease. Why? When will it increase and when will it decrease?
Sir, when it is increasing returns to scale,
Huh.
then it will increase.
So, just what you are right, but just think about it, why does it happen?
Sir, because if we are producing one more unit, the cost we are implying is less than the previous unit. Sir,
So it could be like one labor can produce 8 units and
two labor can produce more than 16, 17,
more than
16.
16, but if there are more workers coming in, then their productivity would fall, and then one labor could produce less than 8 units, like 7 or 6, so variable cost would rise.
Okay. So, see simply what is happening, when we are talking about average variable cost of producing, on average 1 unit, as we are producing more and more and more, what would happen? Typically, remember, when it is related to marginal productivity, that I am going to show you little later how it is related to marginal productivity. What did we see earlier from the table? That in the beginning, when we bring one more worker, let us see that capital is fixed and we are increasing the labor. When we are bringing one more worker, the output is increasing at increasing rate, but after some point of time, what happens? By bringing one more worker, output starts decreasing. So, that will translate into the average variable cost. So, it may happen, I am not saying it is true, it is possible that you get something like this, average variable cost is increasing linearly, or it is also possible that average variable cost remains the same I just talked about. But typically what we get, that average variable cost first decreases and then increases.
Yes, sir.
Fine. And if we bring it, what will happen to the average total cost? It decreases and then it starts increasing. Fine. Is it clear?
Yes.
Yes, sir.
Okay. And also, if you look at this graph, average variable cost and average total cost, if I bring the same graph here, what happens? That earlier, look at it here, average total cost is nothing but average variable cost plus average fixed cost. As Q is increasing, average fixed cost is
Decreasing.
falling. So, what happens as you move further and further? These two, of course, this one is average total cost and this one is average variable cost. As you move, the earlier the difference will gradually decrease.
The difference is equal to the average fixed cost, right?
Okay. again it is not perfect, but let us see. Fine, as we increase q, the difference will keep on decreasing, and for very high q, average variable cost and average fixed cost are going to be equal of each other.
Average variable cost and average total.
Average total cost will be equal to each other. Yes. Fine. Okay.